for this function, I'm supposed to find a power function model for the end behavior. And I'm supposed to identify any horizontal asymptotes. So when we're talking about end behavior, we're talking about the limits as x approaches infinity or as x approaches negative infinity. Because I'm always figuring my function is starting, I'm thinking about it, that my function is starting here at the origin. I mean, it really doesn't start at the origin, but in my brain, that's kind of how I visualize it. And then the function starts doing stuff out here, and I want to know what is that end going to do, and what is that end going to do. I want to know what is the behavior of the ends of the functions as x approaches negative infinity on the left, and as x approaches positive infinity on the right. So let's look at this function, and let's focus on this as x approaches infinity. So with this function right here, as x gets bigger and bigger and bigger and bigger and bigger, and my numerator, the only thing that's really going to count is my highest power. All these other ones, even though x cubed is going to be a big number, and 4x is going to be a number, and 1's going to just be 1, they are going to be insignificant compared to x to the fourth. As x gets bigger and bigger and bigger, x to the fourth is the dominant player in my numerator. And in my denominator, again, my highest power of x is x squared. That's just not going to mean anything as x starts to get bigger and bigger. So really, what I'm going to be left with as x approaches infinity is 5x to the fourth over 3x squared. Well, I can simplify that. That's going to be 5x squared over 3. This is what the end behavior is going to look like as x gets closer and closer to infinity. And the same is true as x gets closer to negative infinity. Because what am I going to have? I'm going to have, again, 5x to the fourth over 3x squared. All of these negative numbers here are going to be turned into positive numbers because I have x to the fourth and x squared. So it's still going to be 5x squared minus 3. That's going to be the end behavior of this function in both sides. You could have probably written just x squared because that's the power function. And now to kind of shift into the second piece here of horizontal asymptotes, but we got to think about it. Let's remember, the definition of a horizontal asymptote is the limit as x approaches infinity of a function is equal to a constant b. Well, in this case, we've just determined that the end behavior as x approaches infinity or negative infinity is not a constant. It's a power function. It is 5x squared over 3. So from our knowledge of power functions, that's actually going to have up, end behavior. Quadratic. It's going to be like parabolic in some way. So that's not horizontal. That's something that's increasing. Horizontal is like that. This is something increasing. So the answer is that there are going to be no horizontal asymptotes on the end behavior of this function. So I graphed the function in red, the big function. You can kind of see how it looks. And although we won't be able to draw on this, you can see that the end behavior is going up that way. And on this side over here, it's going up that way. So it is up end behavior. It's certainly nothing that looks horizontal. But I just wanted to show you also, let's look at the power function we came up with. We came up with a power function 5x squared divided by 3. So I'm going to push that. And in blue now you can see, although all this stuff happening in the middle here is very different, the end behavior is very similar. The red and the blue are tracking one another. So not horizontal, but it just shows you how the end behavior is really determined by the highest powers of x and the leading coefficients.